Good afternoon, it's already the next day. So today we're talking about the part 4 of a 5-part video series on data transformation and manipulation using dplyr in R using RStudio. So today we're going to talk mostly about mutate. So we have talked about filter our first video where we actually choose the row that you want. We also talk about arrange, when how you arrange the rows based on a certain value or alphabetical order. We have talked about the third one, which is the select. So that is how do you want to select a different column that you want for the further analysis. So mutate is a function that actually create a new column. So based on the original code that I take out of the website, so it's a job for mutate. Mutate always add new column at the end of your data set. So let's just try to actually see our first example over here. So first thing was always good to try to revert the data frame back into its original state, so we are not having some problem of previous analysis come over. So we actually let's do our first example. So this is our data frame, which is flight, and once we add mutate new column equals 1, so you can see the output over here. If we go to the back, you can see there's a new column with everything just 1. Okay, so if we just want to try another value, let's say 10, so you will actually add another value with a base of 10. So if you do want to use this value based on the other column as well, you just type in hour, so maybe it's hour times 2. Doesn't make any sense, but it serves the purpose of the example over here. So you can just see new column equals to hour times 10. So when it's a 5, it's a 10. When it's 6, it's a 12, and so on and so forth. So it's just very useful for us to want to calculate things based on the current column that we have. So we have actually faced this example in the past, in the last video, I believe, where we want to calculate the speed. So the speed of an aircraft is the distance traveled divided by the air time over here. But we cannot actually show the value out last time. We can only show the arrangement. But we can't actually show the value in a ggplot or in a table form. So with that, we actually need to use mutate. So let's try to complicate things a little bit for us and try to actually calculate that out. So this is a 2-step function. So the first section of the code, let me just arrange it over here, is actually a select. So select the number of columns that you want. So they select from year to date. So if you go in front of the data frame here, year to date is the first 3 columns. Anything that ends with delay means you select departure delay and arrival delay, and select the distance and air time. So distance and air time over here. And then once we got that smaller data frame over here, we want to pipe it into another, we run a second equation over here, which is mutate. So in this case, we're taking the data frame over here and we're adding 2 more columns, which is gain and speed. So gain will be departure delay minus arrival delay. That will be the time that you gain over the aircraft, if that makes any sense to you. So speed is actually distance divided by the air time times 60. So that will convert the hour into minute. So on. I'm not too sure why they actually do because there's no actually any unit listed out over here. So this is actually taken directly from the GitHub page. So I'll link that in the description down below as well for the answers. Okay, so instead of actually running it as a separate equation, we can also use something called mutate, which actually transmute, which actually will remove all the previous data instead of what we do like this previously. Okay, transmute might not be a really good example for this case. So in this case, we're running it as 2 different equations. So let's go back a little bit. So what we could have done as well is actually use the normal piping function, which is this, and we can just do the same select over here, but just delete the data frame. Okay, so this will be the first stage of the equations, and then you pipe it into a second equation, which is the mutate. And same thing, just remove this, and you should be fine after you do a little bit of adjustment again. Okay, so that's basically let me just cross this out again so I don't get confused myself. So if you run this and you run this, you essentially get exactly the same output. It's just a different format. And in this, you actually run it as a separate equations, separate functions, and you have to actually assign it to a new variable or a new object. But in the second one, you don't, you just go directly in the calculation. So this might actually be more memory efficient because they won't have to save another object. They will just directly do 2 steps at one time. Okay, so once we're done with that, let's go for another new section which is mutate and transmute. So we have already know about mutate. We actually go for new hour and new minute. So in this case, they're just calculating by departure time divided by 100 and departure time divided by not divided by. So this is you divide by 100, but you take only the whole number and not the remainder. While the second one, you only take the remainder. So you can see new hour and minute is 5:17, and if you actually go for the beginning departure time 5:17 is 5 o'clock 17 minutes in the morning. So new time and hour will actually split that out for easy calculation later. We'll see why we need to do that later. Okay, so the new one that I actually want to introduce here is called transmute. So what is transmute is that mutate adds 2 new columns while transmute only retains 2 columns. So if you only need these 2 variables in the next section, it essentially throw away everything else. So that reduces, of course, the memory footprint during the calculations and potentially make the calculation a little bit more efficient than it should be. So you can actually think of transmute as mutate plus a select. So you will actually only select the new column that you have done. So that's basically everything with mutate. Let's go into our exercise. So with all the video series around here, there will be exercise by the end of each section. You can actually download the code into the video from the video description down below. Will again bring you to a website and open the Google Doc. So once you copy paste the Google Doc, please open here, select our notebook and paste it in. Then you should be able to do this together with me, with or without the answer. There will be both versions of the website. So let's look at the first question. So currently departure time and scheduled departure time are convenient, but it's hard to compute because like I said just now, 5:17 is very hard to calculate. Rather, you need to split them up and calculate hour and minute differently, basically. So in this case, what we want to do is that we want to convert the number into something called number of minutes since midnight. Okay, so let's revert our data frame. So let's just walk you through what we done on the first, section over here. Yeah, section over here. So in this case, I have calculated departure time into something called departure time new. So we look at our departure time, which is 5:17. What this equation do is that it divide by the 100 and then only take the whole number, which is 5, we times 60 of it, plus the departure time divide by 100 and take the remainder. So 5:17 essentially means 5 times 60 plus 17. So what this actually means is that 5:17 a.m. in the morning is actually 317 minutes from midnight. So it just convert everything into midnight. Yeah, into minutes after midnight. So this is the definition that we want. So we also do the same thing with a scheduled departure time. And if we do want to replace the column, you can actually use the same name. I do not recommend this. This will actually mess up a lot of things and make things a little bit confusing in the long term. So in this case, if you're using a different name, they'll create a new column. But if you don't, you use exactly the same name, it will actually create a new value and replace the current column. So in this case, you can see we have 21 column running the first, equation here. But if I run the second equation here, you can actually only see 19 column because they have actually replaced the value into the original value. So you won't actually create a new column. So it depends on what you want to do downstream. Both, none is correct, none is wrong. Depends on how you use it. Let's go to our second question. So compare airtime and airtime minus departure time, which is the gain. What do you expected to see and what do you do to fix it? So in this case, I seriously have no idea how to explain. So in the first part of the solution here, we just convert everything into minutes as what we did last time. Just convert to minutes so that we are able to actually calculate them. So then we transmute into 3 more columns. In this case, we have airtime minus departure time. We have the air time and the difference between the two columns. And there are actually a little bit of offset in between them. I have seriously no idea. It could be that the airplane is trying to lift off but it's waiting on someone else. So it's already departed but it's not yet on air. So they're waiting at the runway or something might happen. That's why we might have a minus 34 and plus 77. It could be also that the way they record airtime is different from departure time and so on and so forth. I have no idea. But this is how you can use Transmute to troubleshoot this problem. It's more of a human problem and how the database is being calculated and so on. Okay, let's go to the third one. So compare departure time, scheduled departure time, and departure delay. How do you expect these three numbers to be related? So in this case, departure time plus departure delay should be the scheduled departure time. The scheduled departure time plus departure delay should be the departure time. So using the same calculation that we have, we should be able to directly compare that if all of the departure time is equals to scheduled departure time plus departure delay as the equation calculated over here. So there's also necessary to use a new function called near, which you can go to the website and try to see. So the near function is very similar to the equal function, where 1 equals 2, it will give you a false, 1 equal 1, it will give you a true. The problem is that with floating numbers and doubles, 0.0333333334 might not be equal to 0.33333333. So the way that they're truncated and the way that they calculate floating points might cause a problem. So near would be able to calculate like 1/3. 1/3 is equals to 0.33333. So they're able to accommodate this kind of slight differences in the calculation of floating numbers. So this is what we're using over here. Okay, so in this case we are using we're running the calculation and we transmute into a new column, and the new column will actually calculate the departure time, scheduled departure time, departure delay versus the departure time. So why do we do the 60 times 24 is because we do not want to include the the value over the next day. So if it's over the next day, we will cut down it to, you can either throw it away or you can minus 1440, which is the number of minutes per day, and then equalize them on the same day. Otherwise you get a little bit of errors over here. Okay, so if we actually calculate this thing, you can actually see we'll get one more variable called all. So all is actually just compare between the two variables if it's true or false. And if we calculate the number of false over the total number of row, we realize that 97.5% of all the data is correct. So departure delay plus scheduled departure time is very near to the departure time for 97.54% of the case. So just to use the other approach, which is actually plot the data out, we can actually use the second equation functions over here, where we first mutate by adding the two columns and we filter out based on the scheduled departure time plus departure delay. So this is the same concept over here, where we ignore anything that is above the day, and we actually run a ggplot and we run a geopoint. So in this case, it will be a little bit clearer on how the data is being visualized and how there is the relationship of the data between one of the other. And then because it's actually 336,000 lines, it's gonna take a while to actually plot the data. So let's just wait a moment. We'll come back to this in a while. Maybe we'll just go to the next. Yeah, it's come up. So you can see that most of the departure time versus scheduled departure time, departure delay are exactly the same with each other, and those that are not might be a little bit offset between like 1 or 2 minutes, and it's not going to be significant enough to affect the trends over here. Okay, let's go to the next one. So find the 10 most delayed flight using a Wrangling function. How do you handle time? So time means that if they are 1330 and 1330, we do not want to get them to be separate. So we want to include only the top 10, even though they are. So if two flights has the same delay, we want to ignore the ties, basically, if that's what that means. So let's just have a look at the two functions over here. The first one is DESC. So we have used this in the arrange up above. So what does it do is that if you have a vector between like 1 to 10, it will actually give you -1 to -10. So this will be able to rank them properly. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The corresponding vector for arrangement is -1 to -10 respectively. And if we reverse the vector, you realize that the whole vector changes directions. So when you arrange them, they will go back to the same orientation, basically from 1 to 10. So then we do a min rank. So a min rank is very similar to the arrange, but what they do is that they will rank them based on 1 to 10. But the special thing in min rank, you can actually realize that in the second equation, I have 2, 8 over here. So how do it rank is that you rank it as 1, 2, 2, 2, and 5, 6, 7, 8, 9, 10. So because they are the same number, they will rank them all at 2, but they will actually not count the next one as 3. So it will only return the top 10, even though they are exactly the same in some of them, which is what we meant by handle ties in the earlier statement. Okay, so if we can actually just have a look at min rank decrement in the departure delay, we can see the exact order of what they are. So maybe we can have a look at a little bit more. So 10, so you can actually see the 10 of them, and it will give you the exact order on how to order the departure time or the rows in the data frame as above. Okay, so let's run the last one, which is filter it based on -10. So anything that's more than 10, throw it away, we don't care. And we arrange based on the top 10 to 1. So this is basically the top 10 to 1. And if you want a much easier way to do it, you can also mutate another column in the back called ranking. Doesn't really matter in the case. And I mean, like, let's just work it out. You know, I like to do this kind of thing where you know, I don't prepare things beforehand and I will talk about it. I try to think that, yeah, you know, why don't we just, you know, do it in real time and see what happens. So, and ranking equals to the same, and then we pipe this into the next one, and we arrange based on departure delay. So there's 1 or less, so there's something wrong with the things here. So we should have 1 more. Yep. Okay, so if we do this, we should be able to get a ranking in the back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's actually no difference between the ties, but this is how you'll be able to rank them quite easily. Okay, so that's basically done for our mutate and transmute. We're done with 4, which is filter, arrange, select, and mutate. So mutate, just add 1 core column, and if you only need that 1 column, you can usually use transmute. So we will see you in the next video, which is summarize. And for now, bye.